Imagine this: humanity zipping across the galaxy faster than light, visiting distant stars in hours instead of centuries. It's the stuff of sci-fi dreams, like Star Trek's Enterprise or Star Wars' Millennium Falcon. But what if warp drives aren't just fiction? What if science is edging closer to making them real? Today, we're diving into the wild possibility of warp drives, the latest breakthroughs, the next steps, and what this could unlock for our future. Buckle up, let's warp into it. To understand warp drives, we start with a big hurdle: Einstein's theory of relativity. It says nothing can move faster than light, about 300,000 kilometers or 186,000 miles per second. That's the cosmic speed limit. But in 1994, physicist Miguel Alcubierre threw a curveball. What if instead of moving a ship faster than light, we move space itself around it? Alcubierre's idea, now called the Alcubierre drive, suggests compressing space-time in front of a spacecraft and expanding it behind. The ship sits in a warp bubble, riding a wave of warped space. Technically, it's not breaking Einstein's rules because the ship itself isn't moving faster than light. Space is doing the work. There's just one catch. In order to make it work, we need exotic matter with negative energy, something we've never seen in nature. For years, it was dismissed as a fun thought experiment, too impractical to pursue. But fast forward to 2021, and things got interesting. Physicist Lentz published a paper rethinking the warp drive. He showed it might be possible without exotic matter, using positive energy instead, like what we already know exists. The trick? Incredibly complex arrangements of energy fields shaped by advanced math. Lentz's model still demands copious amounts of energy. Think the output of a star. But it advanced the idea from impossible to wildly difficult. Then, in 2024, a team at the University of Alabama ran simulations suggesting we could tweak these warp bubbles to use even less energy, maybe someday within reach of a futuristic power source like fusion. The research is still theoretical, but it's sparking real excitement. So, what's next? Step 1. More math and simulations to refine these wild ideas and chip away at the energy problem. Step 2. Small-scale experiments, maybe nudging space-time on a tiny level with cutting-edge tech. Step 3. Rallying the brightest minds and resources worldwide to turn theory into something tangible. It's a long game, but the wheels are turning. It's not happening tomorrow, decades, maybe centuries away. But if we crack it, what could warp drives unlock? Picture this: a trip to Mars in minutes. Proxima Centauri, our nearest star system, would be days away instead of tens of thousands of years with current technology. We could explore exoplanets up close, hunt for alien life, or even colonize the galaxy. Beyond exploration, it's about survival. If we wish to survive as a species, Earth cannot support us forever. When the next existential crisis arrives, whether climate collapse, an asteroid, or supervolcano, warp drive would give us access to new homes among the stars. And philosophically, it would rewrite our place in the universe, turning humanity into a truly cosmic species, perhaps fulfilling life's imperative to survive, thrive, and spread as widely as possible. Warp drives are still a long shot, a glimmer of possibility in equations and dreams. But science thrives on chasing the impossible. From the Wright brothers to Apollo, history shows us today's fantasy can be tomorrow's reality. What do you think? Will we ever warp beyond the stars? Drop your thoughts below and subscribe for more journeys into the unknown.